So what we have is another factoring example where basically our a is not equal to 1. So when we're talking about a is not equal to 1, we're talking about this term here. This is our a term. So because that's not equal to 1, there's a different way of kind of factoring in order to figure out what the factored form is. So just like our last example, you're trying to get this factored form of your two parentheses just like this. Okay, so let's go ahead and get started. So the first thing you want to do is find your first and last term of your trinomial expression. So the first thing I have my 5n squared. So that's just going to go in this box. And then my last term, my positive 12, I'm just going to put in this box. So whatever your first and last, they go in these two boxes over here. I want to move this out of the way because I need this extra space up here. So here we go. So once you fill those in, you're going to take the numbers that you have, my 5 and the 12, or whatever number you have, and you're going to multiply. So 5 times 12, I get 60. Now I have to come up with a bunch of factors in order to help me figure out this particular number. So I'm just going to start with my first one. So 1 and 60. 2 times 30 gives me 60. 3 times 20 gives me 60. 4 times 15 gives me 60. 5 times 12 gives you 60. 6 and 10. And that's pretty much it. Those are all our factors. So we have 6 different sets that we can possibly use. Now, I'm going to take a look at this symbol here. And this kind of tells you again what type of signs you're going to have here. So if this is positive, then that means both factors have the same sign. So in other words, that means it's either both positive or both negative. So I got to figure out which one it is. So I take a look at this one here. Since this one's positive, that tells me that they're both going to be positive in our case. So positives and positives. So that means all these are positives. I don't have to worry about anything about subtracting or anything. So that's basically what I'm looking for here. So just like the previous examples, you're basically just trying to figure out who can add up or subtract to give you 19 in our case and add. So if I go ahead and kind of figure this out, 1 plus 60, that's 61. 2 and 30, that's 32. 20 and 3, that's 23. 4 and 15, that's 19. 5 and 12, that's 17. 6 and 10, that's 16. So out of the ones that we have, this is our perfect match here. So I'm going to set it up as 4n and 15n. So how we have to factor, so you fill these in. So 15 and 4. What I have to do is I have to figure out what numbers can multiply or the factors of each certain part. I have these two rows here and then these two columns here. So let's go ahead and set that up. So I have a 15 and a 12. So what number can I divide out of 15 and 12? Which number do they have in common? Well, I can easily divide out a 3. I take a look at my next one. I see I have a 5 and a 4. They really don't have any numbers in common except for 1, so there's no number that I want to factor out. But if you notice, they both have an n. So how many n's can I take out of each one? I can take 1 here and 1 here, so n. And that completes this side. So now I got to look at this column here. So I have a 5 and a 15. I can factor out 5 from here and a 5 from here. And notice that they both have n, so that means I can also factor out an n. I take a look at this next column. I have a 4n and a 12, so the number I can take out of each one, I can take out a 4 here. And then what you're going to be left with, since they don't both have n's, only this one, I can't take out an n. So our final factored form using box method is like this. I have n and 3, so n and a positive 3. I have 5n and 4, so 5n positive 4. Okay. Now, what happens if I have that same problem, but I want to do factor by grouping? Okay. Well, factor by grouping goes through the same process of basically setting up your parentheses, and I'm putting down my first term and then my last term. I do my numbers again, 5 and 12. So we already know that answer, so we know it's 4 and 15, just like before. So I'm going to do 4n, 15n, and then I go ahead and see what I can factor out of each one. So I have 5n squared and 4. 5 and 4, they have nothing in common except for 1, but they both share an n, so I can easily factor out n. So I'm going to have 5n plus 4. I took one n out of here, and I took this one's n away and put it out front. Now I take a look at the second one, 15 and 12. So what number do they have in common? It looks like they're going to be able to take out 3 out of each. So I'm going to put plus 3. 15 divided by 3, 5. This one has an n, so I put the n back. 12 divided by 3, I have 4. So if you take a look, this is how you know you're done. Are they the same? 5n plus 4, 5n plus 4, perfect. So that means these two come together, n plus 3. And then this one basically forms into this particular pair here. Okay, so this is just another method of factoring with these a's when it's not equal to 1. You can either use this method, or you can easily use this box method. Okay.